Hello everyone, this is Sudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. Today I'm going to discuss a topic of electrical circuit and network. So electrical circuit and network has a very vital role for electrical engineers. This subject helps the students to solve different types of circuit analysis, complex circuit analysis. This is all the time helps the students. So the lesson plan is here for this particular subject. Now the today's topic of discussion is problem and solution of. So today we are going to talk about the problem. We will choose some problem and then we'll talk about the solution of active power, reactive power, apparent power and power factor. This is the topic. So in this lecture we'll talk about how to solve any problem of active, reactive, apparent power and power factor. Now, so for that reason, first we have to consider some problem. So here we consider a AC circuit. In this AC circuit, we have a sinusoidal voltage source with 50 hertz supply. Then impedance Z equals to R plus J XL, inductive load, XL, inductive reactance, and the value is 20 plus J 15. That means R equals to 20 and XL equals to 15. So these are given in the problem, and with this the supply voltage is 100 volt, 50 hertz, standard 50 hertz, and the load impedance is 20 plus J15. That is also given in the circuit diagram. Calculate the current flowing through. So you have to calculate the current flowing through the circuit. You also need to calculate active power, apparent power, reactive power, and the power factor of this given circuit. This is our aim. Now, I already told you in my previous lectures that when it's a problem, when it's an example or exercise, anything related with numerical problem, first you have to identify that what are the values which is given in the circuit, number one, and what is the problem, that what is the value you have to calculate. So if you can identify that thing, that questions, it's not so tough to solve the problem, because after that you need to remember only the circuit diagram. Then it is very easy to solve the problem. So this is our problem. We already identify what are the given values and what is our aim from this problem to calculate. So here it is given that Z equals to R plus J XL. So the value given is 20 plus J15. So this one is already given in the problem. Now converting the impedance to polar form, we get impedance to polar form means, this is the question. Here it is given Z equals to R plus JXL, that is equals to 20 plus J15, but here it is given 20 angle 36.87 degree. So that means converting the impedance, we have to convert it from 20 plus J15 to 20 angle 36.87. So you need to understand that is first, otherwise. So let me explain that how can we convert 20 plus J15 to Z equals to 25 plus 25 angle 36.87. Now Z equals to, the value given is 20 plus j15 ohms. Okay, it is actually given in x plus jy form, but here the form polar form means we know that r theta form. Okay, so r is 25 and theta is 36.87 degree. So how we need to understand that how to convert x plus jy to r theta. It is really easy because we know that r equals to root over x square plus y square. This is x, this is y, x plus jy. So putting the value this 20, so r equals to root over 20 square plus 15 square. So 20 square plus 50 square means 20 square plus 15 square, that is equals to 400 plus 225, 625, 400 plus 225, 625, and we know that this is equals to 25. So the value 25 is there. So in this way we can find the value of r from the given problem. Now how to find this theta from this problem? Finding of theta is also very easy because you know that theta equals to tan inverse y by x. This is x, this is y, this is x, this is y. Very easy. Just put the value and using the calculator. If you put and use the calculator, you get the value is 36.87 degree. It's very easy and easy to calculate. But the question is from where these values, from where this equation x equals to r theta, r equals to root over x square plus y square, and the value theta equals to tan inverse y by x, this is coming. You need to understand that part also. So suppose this is x-axis, y-axis. You may consider a point here, okay, and the distance from the center to the point is, suppose this is 0 0. Consider this part is 0 0. You all know. There is no doubt with this. Suppose the point P is here. The distance from the point P to the center is R, and then this distance and this distance. So along x-axis, along y-axis. So this point is P point, and here it is xy. This R is theta. So if we consider this value is x, so this will be y. That means this should be equals to y. Now, what is r? Applying Pythagoras, this up to this, from here to here, this is x. This part is x, and this part is y. So what will be r? R should be equals to root over x square plus y square. So I simply use this formula and put the value 20 and 15 square, that is equals to 25. What is tan theta? Tan theta equals to height by base. So tan theta, what is height? Y. This is base, y by x, that means 15 by 20. So theta will be equals to tan inverse 15 by 20. So in this way, we can find the value of the polar form, the r x equals to r theta. So this is the method of conversion from x plus r plus jxl to z equals to r theta form. So here we use this formula, very simple formula, and using the formula we calculate the value of the z. Now we have to find the current flowing to the circuit. And as per the Ohm's law, we know that current I equals to V divided by Z. V is given in the problem, that is 100 angle 0 degree, and Z equals to, we already calculate, this is 25 angle 36.87. For this reason, for this division calculation, we convert the Z from x plus jy to polar form. Okay, because for division and multiplication, we cannot use x plus jy. We have to convert it from x plus jy to r theta form. But for addition and subtraction, we have, if there is any polar form, we need to convert it from polar to r theta to x plus jy. So this is simple. 4 angle 0 degree minus 36.87 degree. Okay, so for that reason, this value is coming 4 angle minus 36.87. So what is actually the formula? The formula is very easy. Suppose this is R1, so it is R1, R2, phi 2 angle. What is the formula? R1 by R2 angle phi 1 minus phi 2. This formula we use here for this section to calculate the value of the current, that is equals to 4 angle minus 36.87 degree. So in this way we can find the current of the circuit. Now we have to find the active power. So we know that what is active power. Active power, there are two equations to find the active power. The first one is P equals to I square R. I is the current which is flowing through the circuit. The current flowing through the circuit is 42 and the resistance is R. This is 42. This is not 42. The value of I, what is the value of I? 4 angle 36.87. So if we square this, we'll get 42 into R value is given in the circuit, that is 27. So after multiplying, we'll finally find the value 320 watt, or in some other way we can also calculate this. What is that? That is VI cos phi. So what is the significance of this? Because this is the formula of the active power. We already learned this in our previous lecture. So P equals to VI cos phi, means equals to VI cos phi. What is V? 100 angle 0 degree. What is I? VI, I is 4 angle minus 36.87 degree, and the value of cos phi. We already find the value of phi in our previous lecture. So what is that? I is 4 angle 36.87. So phi, so it is because the angle between the voltage and current is 36.87, because this angle is 0. So 36.87. So if you put all these values and calculate, so the value will be 320 watts. This way we can find the value of the real power from the given circuit. Next, this is the active power equation. Now it is the apparent power equation. You all know that apparent power equation is equals to VI is 100 and I is 4, that is 400 VA. Next one is the reactive power. So reactive power Q equals to root over S square minus P square. So what is the S? Because from the power triangle we find that Q square equals S square equals to, from power triangle what we find, that P square equals to, no, S square equals to P square plus Q square. So Q equals to Q square equals to S square minus Q square. Q will be equals to root over S square minus P square. So that formula we use here, and now simply put the value of S and 320 that is already measured in the circuit. Putting that value will get the reactive power is 240 VA volt ampere reactive. Now the power factor. The power factor part, power factor we know that the equation, one of the equation of power factor is cos phi. So cos, the phi value is 36.87. So cos 36.87 equals to 0.87 lagging. So it's an inductive circuit, so it is lagging. Now let me talk about some very important and very interesting question, the multiple choice type question of this chapter about the three types of power and power factor. The first one is, what is the maximum value of power factor? Do you know what is the maximum value of power factor? What is power factor? The power factor is cos phi. So what is the maximum value of cos phi? Will get the maximum value of cos theta is 1. So because the cos value is, when cos 0 it is 1, when cos 90 it is 0. So the answer, think about the answer. What is the maximum value of the power factor? 0.5, 1, 1.5 or 95, 0.95. Think about it, and then this is the answer. The value of the is B, that is 1. The maximum value. What is the maximum value of the power factor is 1. Now, the next slide. Look, this is also very easy and important one. Active power and apparent power are respectively which one? Respectively represented by, this is the question. The active power and apparent power are respectively represented by, which one will be the answer? The active power. Active power is kilowatt. You know it is kilowatt active. And the apparent power is, think on it, which one will be the equation of apparent power, volt ampere. This is volt ampere. So which one will be the answer? Look, kilowatt active power is kilowatt. So how many kilowatt option is there? One is kilowatt, one is kilowatt. So answer will be maybe A or D. Now search the second one, apparent power. kVAR is not apparent power. This is reactive power. Volt ampere reactive. So which one will be the answer? kVA, kilovolt ampere. So D is the answer. So D, kilowatt and kilovolt. So you need to analyze, you need to identify, you have to understand that what is given, what is the problem. Then only you can solve it. Next question. Which among the following happens in a low power factor? So in case of low power factor, what happened? Number one option, large kVA rating of the equipment. Yes, it may be happen. Large volt ampere rating. Greater conductor size. Yes, which among the following happens in low power factor? Great. Reduced handling capacity of the system. Yes. So which one is the answer? Think on it. Now move to the next slide. The answer is the all of the above. That means low power factor, all the three steps are responsible in a low power factor. Next one, for a consumer, what is the most economical power factor? 0.85. So I think you all know that power factor, the maximum value of power factor cos phi is 1. So we can just cut these two, 0.25 lagging, 0.25 to 5 lagging. So answer will be within these two. Either it is lagging or leading. Now think on it, with the most economical power factor, 0.85 to 0.95 lagging or leading. Think on it. Write your answer. Then the answer is lagging, because for inductive circuit get the correct answer. So the correct answer for the previous question is 0.85 to 0.95 lagging. For the consumer, what is the most economical power factor? So C will be the answer, 0.85 to 0.95 lagging. So this is the reference I use to make this PowerPoint presentation. And my request to all of you, please follow the books. There are different types of books in market. The books are available in the market. So you have to follow the book, because using the book you can clear your concept. There are so many exercise, there are so many examples are available in the problem. So if you go through the books, your concept will be more clear, and you have to practice more and more. Then only you will be successful to solve the difficult types of problem. To solve the difficult types of problem of circuit analysis, first you have to realize, you have to remember the equation, you have to realize all the steps of the problem. That is very easy. So need some practice. So for that, books are the most important part. So solve different types of exercise and examples from the books. For any doubt, any confusion, you can contact with me anytime. Thank you all. Thanks for the watching lecture. Thank you everyone. Best of luck.